Well, hello everyone, and welcome to the first of three videos about sort of a review of what we think you know from general chemistry that concepts you're going to need to rely on as you go into Chem 2100 or Organic 1. Many of the topics that we're going to be looking at here can be found in Chapter 1 and 2 of the Klein textbook, but in particular, I'm going to focus in this particular video on things that come out of the Chapter 1, and again, are things that we think you know in first year chemistry and would have been covered either in Chem 1100, 1110, or whatever other first year course you took to get into this room. One of the things in those first year courses was the structure of the periodic table, and so here's an abbreviated version that we like to use in organic chemistry. And so here, the transition metals are in the center. We won't see many or if any of those in Organic 1. You'll see a few of those in Organic 2 if you stay on to go there as well. And one of the topics, or one of the things that we think you learned quite a bit of in first year, is the electronic configuration of the so-called first row elements. And so how the electrons built up in those orbitals and what orbitals are, and how those electrons build up, things like the Aufbau principle and Pauli exclusion principle. And this diagram on the screen here, we hope, is something that you've seen quite a bit before. We're going to focus on carbon, as you might imagine, in this course. And carbon, if the electronic configuration of carbon is shown on the screen here, so-called 1s2, 2s2, 2p2, and if you look at that electronic configuration of carbon, the prediction you might make based on that electronic configuration is that there's only space for two covalent bonds, for example, to a hydrogen atom, where their covalent bond is the sharing of two electrons between two atoms. So you might predict, based on that electronic structure, that carbon could only make two covalent bonds, as we've kind of indicated in the cartoon here. What we actually observe about carbon is that it has the ability to make four equivalent covalent bonds with the shape shown here. We think you learned a little bit about that bonding and shape in first year chemistry as well. Now, our explanation for this observation of four bonds in carbon is that those orbitals in the carbon atom can hybridize to make four equivalent or four degenerate hybrid orbitals, so-called sp3 orbitals. And those have you have electrons in there that can match up to make four carbon-hydrogen bonds. And those hybridized orbitals are our explanation for the observation of the number of equivalent bonds that we observe in a carbon atom as well. And so we can get some cartoons that kind of show that equivalent sharing, or the equal sharing of the electrons between the carbon and the hydrogen as well. One of the other concepts that we rely on quite heavily in organic chemistry is the concept of electronegativity. And this is a concept that describes how equal a pair of electrons are shared in a covalent bond, either between two of the same elements or two different elements on the periodic table. And so the trend is shown here in a table, and the absolute value of the numbers, while it's a bit helpful if you remember them, matters a bit less just remembering the general trends on the periodic table, that as you go up the periodic table, it's increasing electronegativity within a group and increasing electronegativity as you go across that group, with fluorine being the most electronegative element. And it's the difference in those electronegativity values that help us predict the characteristics of a particular covalent bond. So if there's a large difference, so things like ionic bonds between a sodium and a chlorine, that those electrons are not equally shared. If there's a very small difference, like for example, between two atoms of the same element, like two carbon atoms, or two elements that are similar in electronegativity, like a carbon and a hydrogen, those are very non-polar bonds. And we'll see a lot of carbon-hydrogen and carbon-carbon bonds, as you might imagine, in this course. And then in the middle are the polar covalent bonds, so things like carbon-oxygen bonds, for example, where there's a carbon, about a 1 electronegativity difference between those two elements, and they're polarized. And we'll rely on that concept of a covalent bond polarization to explain a lot of the chemistry that we see in this particular course. And those electronegativity values explain a lot about the characteristics of a molecule. So for example, molecules that contain only carbon-hydrogen bonds, those are very nonpolar bonds. And so between the molecules themselves, those intermolecular forces are relatively quite weak. Those London dispersion forces or van der Waals forces, although they can add up. So for example, hexane is a liquid at room temperature, even though it's got that very weak intermolecular forces between each molecule, and it's a completely nonpolar molecule as well. some of the more dipolar interactions like that between a carbon and an oxygen, you can see reflected in these these molecular properties. So for example, the boiling point of acetone is considerably higher than that of isobutylene, even though the only difference is replacing a CH2 group with an oxygen. But that polar bond has a big influence on those intermolecular forces. And these are concepts and ideas that we're going to rely on quite heavily to explain lots of things, including things like hydrogen bonding, and we'll see more of that as we go throughout the course. We think you saw this in first year, and just want to point it out here as a bit of a review as well. And so for that, we'll leave it at that for now, and just kind of as a bit of a review of some of the concepts we think were important for you to learn from first year. And those are in the chapter 1 of the Klein textbook. So if you're struggling to remember some of those ideas, or it's been a while since you took first year, I would go to that textbook and kind of review some of that as well. We'll have some more videos on chapter 2 and 3 material posted as well.